In this video, I want to provide a quick derivation of the quadratic equation. And the quadratic equation is one of these equations that you'll see in 8th, 9th grade, and it'll be given to you. And you might wonder how in the world is it that for ax squared plus bx plus c equals 0, why in the world would x equal negative a plus or minus, negative b plus or minus b squared minus 4ac divided by 2a? Why in the world would this work? This seems hideously complex. But then, of course, you plug in something and you find that it works, and you walk away and you say, okay, fine, it works. But you never understand why. So here I want to go through a quick derivation of it, and the whole time I want you to be thinking that what we're going to be working towards, there are going to be 2 steps. Step 1 will be completing the square. Going to complete the square. And the reason that we're going to complete the square is that completing the square is going to give us an easy way to isolate x. And step 2 is just going to be to do more algebra to isolate x. And once we've isolated x, we'll just have the problem solved. And of course, there'll also be algebra to complete the square. So let's get on with it. We remember that completing the square involves getting an equation in the form of x plus y squared, where in this case x is our variable, and y is our constant. And well, if we can expand this out, we're going to get, well, x plus y times x plus y equals, well, you get x squared plus, and then you have x squared, and you also have x times y plus y times x, which is also the same as x times y, plus y squared. If we just do foiling out, which equals x squared plus 2xy plus y squared. So we want to get ourselves in this form, and the first thing that I want you to notice is that there's no coefficient on the x squared when you complete the square. So this coefficient on our x squared here in the quadratic, in this quadratic, has to go away, and luckily we can do that pretty easily. We can get rid of the coefficient by just dividing both sides by a. So we get ax squared divided by a is just x squared plus b divided by ax plus c divided by a equals 0. And now we have ourselves a form where we have x squared plus a constant times x plus a constant. So we're set. We just have to find what y equals. And we know a little bit of information about y already. We know because if we rewrite this here, we have x squared plus 2yx plus y squared. 2 times y. This is 2 times y is a coefficient of x, and we know that 2y, this coefficient that we found, 2y has to be equal to the coefficient of x over here, which is b over a. So this tells us that y equals, dividing both sides by 2, b divided by 2a. So this is the first piece of information we know. But if we just go ahead and plug in y equals b divided by 2a into our equation, you'll note that y squared will not equal c divided by a. Y squared will not equal c divided by a. It will equal b squared divided by 4a squared, right? So what do we need to do? we can't change what y equals. We already have a value for y, but we can rearrange our initial equation, this x squared plus b over ax plus c over a equals 0. We can rearrange it such that the third term is a constant b squared divided by 4a squared. And the first step we can take, if we just take our equation down here, is saying x squared plus b over ax, and then just adding this b squared over 4a squared, b squared over 4a squared to both sides, right? Plus c over a equals 0 plus b squared over 4a squared. And we can go ahead and simplify this out. We get x squared plus b over a x plus b squared over 4a squared. And now we can go ahead and just subtract c over a from both sides, equals negative c over a plus b squared over 4a squared. And let's scroll to give ourselves some room now. So we wanted to complete the square, right? And completing the square, as you can see, we now have all the elements that we need to complete the square. So we can just rewrite this. We can rewrite this as x plus, and then our y is 2b over a, x plus 2b over a squared, which is now equaling this entire left side, equals negative c over a plus b squared divided by 4a squared. We got this all right. And now if we continue on after completing the square, we say, okay, well, this is looking pretty good, right? We can just take the square root of both sides, right? So we take the square root, we find that x plus 2b divided by a, x plus 2b divided by a, equals the plus or minus square root. I'm just going to rearrange the terms here, so we have a plus minus, so b squared over 4a squared minus c over a. And here you could just say x equals negative 2b over a plus or minus the square root of b squared divided by 4a squared minus c over a, and you could call it a day, and you would be correct. This is a quadratic equation. This will give you the correct answers for your quadratics, but you might notice it's different from what you see in textbooks, from what your teacher gave you. This is because this quadratic equation is slightly unwieldy, and if we come over here, we can switch back to yellow. If we diverge from our path very slightly over here, if we diverge from our path very slightly and do some factoring and some basic algebra, we can come to a much cleaner version of this. So instead of immediately square rooting here, let's begin by trying to get this side with the same denominator. And how do we get negative c over a plus b squared over 4a squared? How do we get these to have the same denominators? Well, we can say negative c over a times 4a divided by 4a. And this is the same as multiplying by, well, 1, so it's fine. But negative c over a divided by 4a times 4a equals negative 4ac divided by 4a squared. And 4a squared, now we have the same denominator. So this negative c over a plus b squared over 4a squared, this is equivalent to writing here negative 4ac over a plus b squared over 4a squared, and this is 4a squared. But now we can say, okay, common denominator, let's just put the addition first now. B squared minus 4ac divided by 4a squared. And you might already be noticing some parallels here. This b squared minus 4ac is pretty similar to what we have in the radical here. So knowing this, let's replace negative c over a plus b squared divided by 4a squared with b squared minus 4ac divided by 4a squared into this equation. And we'll come down here, say x plus 2b over a squared equals b squared minus 4ac divided by 4a squared. And we're nearing the finish line here. Let's take the square root of both sides, and we'll get that x plus 2b over a. And have I messed something up here? I have. Y is b divided by 2a, and I've been saying this whole time 2b divided by a. So this 2 should be going down here in reality. So don't mind this. Sorry. This 2 is in the denominator. Sorry, my bad. But we get x plus b divided by 2a equals well, b squared divided by 4ac divided by 4a squared. And now we just subtract 2a, b divided by 2a from both sides. We get x equals negative b divided by 2a, and this is plus or minus square root, sorry. Plus or minus the square root of, well, we can write this as the square root of b squared minus 4ac divided by the square root of 4a squared. But the square root of 4a squared we can also write as the square root of 4 times the square root of a squared, right? Just taking out the product. But the square root of 4 is 2, and the square root of a squared is a, so we can rewrite this again as divided by 2a. And finally, we see we have a common denominator, so let's add them together, and let's make this official here. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And this right here is the quadratic equation, and how you get to the quadratic equation. Also, you see that we did all the steps necessary to complete the square, and we did that so that we could isolate x. And once we had completed the square, we were able to isolate x. We were able to do it in there are many more ways, many quadratic equations, but I guess the world has decided that they like this one the best. So that is how you derive the quadratic equation.